In this video, section 7.3, other forms of linear systems. We'll start off with a nice interesting linear system here. 3x plus 2y is equal to 7. X plus y is equal to 5. So, unlike the previous ones that we were looking at, there's no obvious way that we can solve this. There's no x equals or y equals. If we add these guys together, we're not going to, this isn't going to cancel out. We would need 2y minus 2y. All I'd need to do would be to multiply this by 2, negative 2. So let's do that. That's what we want. Let's see if we can make it happen. We're going to multiply both sides of this equation by a negative 2. That way we'll be following the golden rule. So our new system will look like 3x plus 2y is equal to 7. The first equation will remain unchanged. And now the second equation will be minus 2x minus 2y is equal to a negative 10. Aha! And now, just like we wanted, those will cancel out when we add. So x plus 0y is equal to a negative 3. Hey, x is a negative 3. That's just what we wanted. Now it's time to substitute. I'm going to take this value and put it into this original second equation because, hey, look, this is just a single y. That's going to be pretty easy to solve for y. So we'll have minus 3 plus y is equal to 5. Add 3 to both sides. Y is 8. And remember, x was a negative 3. So we've got our solution. Cool. Next system. 4y minus 2x is equal to 10, and x plus 3y is equal to 5. Wow, this is really close, huh? We've got just x to the first power, but this 3y is getting in the way. We want, say, x is equal to, and then we could use substitution. So we'll solve for x. If x plus 3y is equal to 5, then that means that x is equal to 5 minus 3y. Then we can take this and substitute it into our first equation, not the second equation. Always want to be using both equations, otherwise you don't get a solution. And let's see what we get. See here, 4y minus 2 times this expression here, 5 minus 3y, and that's equal to 10. So we'll go ahead and we'll distribute the negative 2. Negative sign gets distributed too. And this will be minus 10 plus 6y. And that's equal to 10, and this 4y is still there. So we can combine these two. 10y minus 10 is equal to 10. So 10y is equal to 20. Y is equal to 2. But we still need x. It's not enough just to get y, but we know what x is in terms of y. So we're going to take this value for y, substitute it back into this expression, and that is, let's see here, x is equal to 5 minus 3 times y, so 3 times 2. X is 5 minus 6. X is equal to a negative 1. And y, as you'll recall, is 2. So we've got our solution. Great. Let's take a look at one last system that is descending dramatically, and it is a spicy one. We don't have any clear method of solution for this. I can't just multiply x by 2 and say this equation, multiply it by 2 and eliminate x, or cleanly solve for x, but I want to try and solve for x anyways. This has only got a 2 on it, so we'll solve for x and see if we can use substitution. We'll subtract 10y from both sides and then divide both sides by 2, and this really isn't that nice, and it's not that pretty. I don't want to plug it back in here and multiply it by 5, so maybe we'll try elimination. Let's see if that gets any better. Now, like I said, we can't just multiply this by 2. I want to get these two guys to cancel out. So I'm going to take this equation, I'm going to multiply it by 5. And then I'm going to take the first equation and I'm going to multiply it by 2. That way we'll have 10x and 10x, and one of these guys better be negative because I don't want any sign errors. So I'll make this one negative. That way I just add instead of subtract, and I can avoid some sign errors. So our first equation will be 10x minus 6y is equal to 14. The second equation will be, see here, minus 5 times 2. That's a negative 10x. Hooray, these are going to cancel out. Minus 50y is equal to a positive 15. Okay, that's a lot going on right there, but that's okay. Always brace. We'll just add these two equations together. 0x minus a 56y is equal to 29. Like I said, I don't really care that these numbers are big because I can still solve. A negative 29 divided by 56 is y. And now I need to substitute this back in to get x. Well, I already solved for x, so I may as well put all this work to use here. And let's see here, x will be negative 3 minus 10 times y, so that's negative 29 divided by 56. And then that entire thing is divided by 2. And technically, yeah, we've got our solution. But we may as well try and simplify x a little bit. Negative 3 times, let's see here, a positive 290 divided by 56. I'm just going to say times 1/2. This is 168 negative 56 plus 290 over 56 parentheses times 1/2. So let's see here. 290 divided by 168 is 8, 10, 2, 2, 1, 122. Cool. So this is 122 divided by 56 times 1/2. Hey, this is, let's see here, that'll give me 61 over 56, and that's x, and then y was negative 29 over 56. Hey, that's better. Cool. Alright, well, that's it for section 7.3. Thanks.